In the beginning of time, horses were wild. They were hunted for their meat, skin, and bones. Since the Middle Ages, horses have been domesticated, and they are used for warfare and transportation, as still used today.
2, 3, 4.
To survive in their environment, horses have utilized physics in their anatomy and physiology. From the positioning of their eyes to the shape of their ears, horses use physics every day. Let's see how. Horse vision consists of monocular vision and binocular vision. Horses' eyes are located on either side of their head, creating a wide and circular view. This panoramic vision is monocular and allows them to view their surroundings on both sides. Their binocular vision is directed down their nose and not straight ahead, which gives them better depth perception. Light waves enter the horse's eye through the cornea. After light waves travel through the iris, waves encounter a small opening in the iris called the pupil, which is the final destination for light. Muscles dilate the pupil of a horse's eye to regulate the amount of light that enters the interior of the eye. Horse focusing in the eye depends upon the wave property of refraction. As light waves pass through the cornea and the lens, light waves bend to pass through the object. Refraction occurs because the medium changes. The speed of wave changes when the medium changes and the path appears to change. Like most animals, horses also use the wave property of reflection to see. Reflected light off an object enables horses to see. Another property of light waves is polarization. Polarization is the aligning of vibrations in a transverse wave, usually by filtering out waves of other directions. Light vibrating in all directions is unpolarized, while light that can find its way through the spacing between atoms and molecules is polarized. Polarization has to do with 3D vision. Humans see depth, or 3D vision, because of the region of overlap between our eyes, or our binocular vision. This is called spectroscopic vision. Since horses' eyes are placed on either sides of their head, horses have a very small angle of binocular vision, and horses see totally different views out of each eye, while the left eye of a human sees the same object as the right eye of the human, but at slightly different angles, picking up different visual information. Therefore, horses have very little depth perception and 3D vision. Like most animals, horses use the retina of their eye to view color. On the retina, there is a layer of cells called receptor cells, the rods and cones of the horse's eye. Rods and cones are called photoreceptors, or cells that respond to light. Rods are more sensitive to light and dark changes and contain a low number of light-sensitive pigment. Rods are not good for color vision. Cones are not as sensitive to light, but are sensitive to colors red, green, and blue. Cones send signal to the brain to perceive color. Horses have more rods and a deficiency in cones. Therefore, horses see a limited amount of colors in the spectrum. A horse's hearing is much sharper than ours. They use their hearing for 3 primary reasons: to detect sounds, to determine the location of the sound, and to provide sensory information that allows the horse to recognize the identity of these sounds. Using 10 different muscles, a horse's ear can move in 2 different directions to hear sounds from 180 degrees around them. A short passageway connecting the outer ear to the eardrum of the horse allows sound waves to travel through it and strike the eardrum, causing the eardrum to vibrate. In doing so, incoming sounds frequencies and amplitude increase, allowing the horse to clearly hear the sounds. The shape of the pinna of the horse's ear acts like satellite dishes to capture sound waves and funnel it into the inner ear. This is a property of waves called reflection. Since the horse's ears are shaped like a dish, the reflected sound of all incident sound generally funnels to the center. The center of the ear is where the eardrum is, causing a strike and vibrations. Since horses are prey animals, they can hear a wide range of frequencies, from 14 Hz to 25 kHz. This makes hearing a very powerful tool for horses.